So the multiplying binomials or squaring binomials, this is where you have FOIL, or you could box method is another way. It all sort of depends on who taught you first, is what I found for most students. I will tell you, if you are on the fence about which one, box method, in my opinion, coming from the person who has the attention span of a squirrel, is the best at keeping you accountable for all of your like multiplication. So it's not as easy to skip one, to leave one out. And hopefully you got through that DeltaMath okay. But the ed puzzle just didn't seem to look, it didn't go very well when I was looking at the grade, like answering the answers you put in. You may have figured it out between now and then, but FOIL is first to first if you happen to learn FOIL, and that's x times x, which is x squared. And then we would do outer, which is the outer edges to the outer edge, which is a -4 times x. And hopefully in the DeltaMath, you realize that really what happens is, the part that's important is one binomial goes on one side and then the other binomial goes on the other side. You can't mix them up, but you can put them on either side. So FOIL first, outer, inner. So that's at x times 4, which is going to give us 4x. Hopefully you can read that with the screen. It doesn't look very good, actually, now that I'm looking at it. Let's see if I can get another color. Brown will have to be it. 4x. I'm not sure that's even a lot better. It's not. And last but not least, your outer. I'm sorry, last. First, inner, outer, last. So, and the color change was just so hopefully you can see how it's the same process, it's just organized differently. And watching students who chose to decide to use box method, even they were FOIL fans in the beginning, you definitely don't leave a block empty. When we FOIL, some students will leave out, one of the sets of multiplication, not on purpose, just because you're boogieing along and then you didn't realize you skipped that one, or something happened and you missed it. So now we're going to pull out, which just means combine like terms. As long as everything is in standard form along the outside, so highest exponent to lowest exponent, or in this case to constant, then you should have all the matching terms by diagonals. If I have $4 but I lose $4, that means I have none. So that would be 0x, and 0x means it's not going to show up. And then minus 16. Anytime there's a positive and a negative, so positive and negative in that binomial, it's going to give you a binomial out, because as long as the numbers match. So if it's a repeat but one's a plus and one is a minus, it will always be a binomial. And this is called a perfect square, because I can take the square root of x and then the square root of 16. And that's where these factors come from. And every time you take the square root of any number, you have a positive and a negative. Now, the part that I'd like for you guys to start practicing doing, obviously we don't want to Desmos. You need to be able to factor. You need to be able to multiply. You need to be able to do all those things. But again, if it's calculator active and it happens to not be multiple choice, there are ways that you can check this and make sure you did it right. Because if it was multiple choice, obviously you could just type it in and go find it. But x minus 4, oh, that's not what we wanted to do. X minus 4 times x plus 4 is what we were supposed to do. And that is our quadratic. And you see that it crosses the x-axis at that -4 and at that +4. And that's what those factors give us, these solutions, x-intercepts, or roots. We always talk about the vocabulary words. There's a lot of words to ask for these two numbers. But these are factors. These are solutions. And then our answer, when we multiplied it together, was x squared minus 16. And if it graphs on top of each other, then we did it right. And you can cut it off and back on just to make sure that it graphs on top of each other. So there should be no reason for you to get it wrong. It might take you a couple guesses to get it right if we're not there, but you shouldn't just run down the rabbit hole of wrong answers without knowing that it is wrong. Okay? So there's Desmos how to check that bad boy. Now this guy is x plus 7 squared. When we learned our exponential rules, exponential laws, you distributed that too, but there was no plus in the middle or minus in the middle. It wasn't two terms, a binomial. It was 7x squared y 4. So it was multiplication and division on the inside is the only time you distribute this 2 in. In this case, that means we're going to write it 2 times. and then we're going to multiply. Now, this is not a plus and a minus, so you're pretty sure, can be pretty sure that you are going to have a trinomial as your answer. Okay? So, again, x plus 7, and you can put the pluses if you want. One binomial on one side, the other binomial on the other side. So first would be x times x, which is x squared. Outer would be x times 7. Inner would be x times 7 again. And then last would be 7 times 7, which gives us 49. Pulling everything out of it, so you multiply into the box. So x times x gives me x squared, 7 times x gives me 7x, 7 times x gives me 7x, and then our last two constants give us that last box. So multiply in, add or subtract or combine, clean up like terms when you pull it out of the box. So 7x and 7x are like terms. That's going to become 14x and then plus 49. Again, you could then go plug this in just as is into Desmos. And then if you want to plug this in after it, just to make sure you're on the right frame of thought before you jump too far. And then last but not least, plug in your answer. And all three should graph directly on top of each other. Have not seen one like this necessarily on the EOC, but it is something you need to be aware of. So this is not x minus 5. That minus is actually applied to your x. So the x is negative. Again, the squared means that not that you're going to distribute that squared in, because there is two terms in here in this binomial. We are going to actually multiply them together, but we have to pay attention to that negative. The negative is not with the 5. It's 5 minus x, 5 minus x, because we write it twice. And then at that rate, we're going to do 5 times 5, which is going to give us 25. 5 times a negative x gives us a negative 5x. 5 times a negative x gives us a negative 5x. And then a negative x times a negative x, depending on how your brain works, that's a negative 1 times a negative 1, which gives us a positive 1, and then 2 x's, so x squared. You can decide to pull out into standard form, so highest exponent to lowest exponent, or you can pull them all out and then clean it up, because you always want to put it in standard form. And that would be your x squared first, because it's our highest exponent. Then we have I owe you 5 and I owe you 5, which means I'm going to owe you 10x. And then last but not least, I have a positive 25. Positive 25. So that guy should multiply out that way. The difference, again, is just paying attention. If you use your box method and you don't try to outsmart yourself or shortcuts, and you literally just take each one and multiply it through, again, you shouldn't run into an issue. We can plug this one in Desmos and our answer in Desmos, and they should graph on top of each other. So just a quick little hit on multiplying the binomials or squaring binomials again. But the really important part, I pulled all of these off of Delta, so they should have been part of your practice last week. Most of you did a great job. Some people did not do it at all. We do want to make sure those get done. I just started teaching this way in the last 2 years, and students have said that it makes so much difference as far as to the understanding. And I hope that's the case for you guys too. You're always thinking about what numbers multiply together to give you 27 and add together to give you 12. So when I went around at Pinecrest and tried to figure out what's one thing that every teacher taught the same as far as factoring, because again, factoring lasts from a freshman math class all the way to a senior math class. It's the one content you will do in every stinking math class. So the sooner we can get good at it, the better. Your life will be easier the next time it comes around. They do an ACB chart. And ACB is A times C at the top, B's at the bottom. So this is A times C. And when I say A times C or B, this is relative to AX squared plus BX plus C, which is what you could call the standard form outline. And you set it equal to 0 for all quadratics to factor. So the X game or the diamond challenge and all of that is just number sense, but we're about to apply it to factoring. So 27, you could do 1 and 27. 27 is not divisible by 2, so 3 and 9. 4 is no good, 5 is no good, 6 is no good, 7 is no good, 8, and then you're back to 9 again. Another way, if you use your TI 83 or 84, if you go to y equals, and I type in 27, all kind of stuff in here, 27 divided by x, and your x is underneath mode. This doesn't work as well in Desmos because it doesn't auto-populate your table for you to give you all the things. But now I can hit second graph, and all my whole numbers are my factors. So not the decimals, just my whole numbers. So 3 and 9, and then it comes all the way back down to 9 and 3 and repeats. So you know you have your set at 1 and 27, 3 and 9. 1 and 27, if I add them together, would give me 28. If I subtract them, would give us 26. We are shooting for 12. 9 and 3 do add together to give me 12. So I can do 9 and 3. I have a positive AC and a positive B. Your B value, especially when we start the factoring, helps decide which one of the numbers might be negative. If B is negative, the larger of the two numbers will always be negative. So if B is negative, the larger of the two numbers will always be negative. In this case, they're both positive. So 9 plus 3 gives me 12, and a positive 9 times a positive 3 gives you that positive 27. So then if I'm going to do the same thing here, so it's ACB, my B is negative, so I know my largest number is going to be negative. If I'm talking about the multiples of 15, so what can I multiply together to get 15, but add or subtract to give me 14? In this case, they're both negative. So 15, we have 1 and 15. 2 does not give me anything for 15. 3 and 5. 4 does not work. Then we're back to 5 again because 5 and 3 would be our set. 5 and 3 will either give me 8 or 2, depending on if I add or subtract. So that's not going to be any good. So we're going to use 15 and 1. B is negative, so we're definitely going to make the larger number negative. So the 15 becomes negative. And a negative 15 plus a positive 1 does give us that negative 14. A negative 15 times a positive 1 gives us a negative 15. How did you guys feel about doing this? Was this too easy? Or do you want me to keep going? More explanation. Okay. Cool. Then I'm going to jump it. So it's not that hard. What I want you to do is make sure you're the confident, and I love it. You're good, confidence. Maintain that, because for some reason we can do these patterns, and then all of a sudden when we try to apply it to factoring, everyone shuts down. It is the exact same thing. You just have to set it up. Okay. I am going to skip the GCF hockey method for the moment and go to these factoring so you can see how the diamond or X game applies to these. So again, we have our X, and this is A times C and B at the bottom. So A would be 1. If we are not super fluent with AX squared plus BX, I'm trying to make him fancier than he is, plus C. So that's the quadratic in the front because it's X squared. That's to the second power. And then we have our linear, just X, and then we have our constant, which is C. So in this case, A times C, we have a 1. So 1 times 45 is what's going to go in the top of our X. Our B value is going to go in the bottom of our X. So 14. So we are going to find numbers that multiply to give me 45 that will add or subtract to give 14. So 45, we have 1 and 45. 45 is not divisible by 2. 3. What can I multiply by 3 to get 45? Or if I divide 45 by 3, what would I get? Yep. So 3 and 15 will multiply to give me 45, and then I'll keep working down my list. 4 doesn't go into there. 5. How many times does 5 go into 45? Good. 5 times 9 is 45. Perfect. And then we can keep working down our list, and I believe the next one is when we get to 9 and 5. So that's our only 3. 45 and 1 are never going to give me 14. It's 46 or 44 at best. 15 and 3 are going to give me either 12 if I subtract them from each other, or if I add them, it's going to give me 18, so that's not going to work. So we have 9 and 5. My B value is positive, so we know the 9 is positive. So if I have $9 and I'm trying to get to 14, which is that B value at the bottom, then I know 5 is going to remain positive as well. Now, as long as A is 1, this is all we do, and we do X plus 9, X plus 5. Now, hear me out. Vocabulary, vocabulary, vocabulary. This is factored. Because, again, the same processes, they last in every one of your math classes. There's like a gazillion questions they can ask about quadratics. And as I've mentioned to you, it's just knowing which part they're looking for. Like you're going to get where you can do these very easily, but have to be able to answer the question they ask, not just throw numbers at it. So factors are the two binomials in parentheses. If it said to solve, this means we're going to take these and set them equal to 0. Both of them. X plus 5 equals 0. Now, trust me, you're going to see a pattern and you're not going to write these down. Especially ESC day or quiz day, please write them down and work them because you will not always have x plus 9, x plus 5. It might be 2x plus 5. It may be 3x minus 9, and then you have to solve it. So it's going to be a great pattern. It's going to look really easy. Just don't undermine yourself for the future. So I need to solve for x. How would I move that 9 if I'm solving for x? How do I want to get the 9 away from that x? Yep, we're going to subtract 9 from both sides. And so that means x equals a negative 9. Then we're going to do the same thing over here for this x. We need to move that 5 over. How are we going to move that 5? Subtract 5, right? Yep, minus 5, minus 5. And that means x is going to equal a negative 5. So when y is 0, x is going to be a negative 9 and a negative 5. You can see it written with a squiggle as a list. And these are the solutions. So if it says solve, answers, what are the answers? X-intercept is the other important word that you'll see a lot. Where does it cross the x-axis? It's going to cross the x-axis at a negative 5 and a negative 9. So depending on what the question asks, factors, you're done right here. If they want you to solve it or find the x-intercepts, how many solutions, then you take your two factors and then set them equal to 0 and solve it. So solve, factor. Okay? All right, so we're going to do the next one. We have x squared minus 7x minus 30. So if we do our big, so it's a times c and b. A is 1. Sometimes it works better if you check yourself and make a little table for yourself. So a is 1, b is a negative 7, c is a negative 30. So 1 times c is going to give me a negative 30. B is going to give me a negative 7. So now we're looking for the numbers that we multiply together to get 30 and get 7. And you can call them negative and negative up front or not. It's up to you. Just make sure before the end we go back and make sure that we multiply to give the negative 30 and add or subtract to give that negative 7. So obviously you have 1 and 30, 2 and 15, 3 and what give me 30? 3 and 10, good. Can we do 4 and get a whole number? No, so how about 5? 5 and what give me 30? 5 and 6, good. And then after 5 is the number 6, so that would circle us back to 6 and 5, so that pair. 1 and 30 will give me 31 or 29, and we need 7. 2 and 15 give me 17 or 13. That's not it. 3 and 10 would give me 13 if I added them, or 7 if I subtracted them, so that looks good right now. 5 and 6 would give me 11 or 1, which is no good. So we're going to use our 3 and our 10. Our B value is negative, so I'm going to make the 10 negative, so the bigger guy's negative. If I owe you 10 and I pay you 3, where am I at that point? If I owe you 10 and I paid you 3, negative 7, which is where we want to be. And negative 10 times a positive 3 gives us that negative 30. So then our factors are going to be positive 3, negative 10. And I'm writing the word again because this is factors. So if it says to factor, we're done. If it says to solve, we're going to do x plus 3 equals 0 and x minus 10 equals 0. I want x by itself. I'm going to move that positive 3. And so x is going to equal what for that x plus 3 if I solve for x? Positive or negative? So it was positive here. So how am I going to move? It's got to move across the equal mark. So the great divide, like we always talk, right? So it's going to become a -3 because it has to flip sides. So over here on our next one with x minus 10, we're going to cross that great divide. That -10 is going to become x equals what? Positive 10 again. Good, because we added it to undo it to the side. The inverse of subtraction, right? And so our solutions would be -3 and positive 10. Solutions, x-intercepts, zeros is another word they use later on as it keeps going along the world of quadratics. Roots is another word. But I feel like if right now today, solutions and x-intercepts, you're good, then you know where we're at and you're fine. All right, let's do the next one. X squared plus 2x minus 24. So I'm going to make my x. What goes on top? -24, right? -24. What goes on the bottom? 2. Perfect. So we're going to find the numbers that multiply to give us AC, so -24, that'll add or subtract to give me 2. So remember, we want to leave our x's alone because all this is dealing with the x's are their own thing. X's are inputs, and then we have coefficients, constants, and answers as well. So 1 and 24. 2 times what gives me 24? Two times 12. Perfect. Then let's do 3. 3 will work. 3 times what gives me 24? Good, good, good. Good. Let's try 4. How about 4? 4 and 6. Excellent. And then 5 isn't going to go in there. And then we're back to 6 again, right? So we're done with our pairs. 1 and 24 would give me 25 or 23 if I added or subtracted them. So that's not it. We're looking for 2. 2 and 12 give me 14 or 10, depending if we add or subtract. That's no good. 3 and 8 will give me 11 or 5, not 2. 4 and 6, though, will give me 2. 6, 4. My B value is positive, so 6 is larger than 4. So I know this 6 has to be positive. So if 6 is positive, I needed to add it or subtract it to 4 to get 2. How am I going to get this 6 to turn into a 2? Add 4 or subtract 4? Minus 4, right? Because 6 minus 4 gives me 2. If I add it together, then I end up with 10. And then positive 6 times a -4 gives you a -24. So that means if I have that 6, that means I have x plus 6 and x minus 4 are my factors. So I've now factored it. So 2 binomials, we factored that bad boy. If I wanted to solve it, if I ask you what the x-intercepts or solutions are, what would you do next? So if I ask you for the x-intercepts, solutions, roots, or zeros, we're going to set equal to 0. Set equal to 0 and solve the factors. So we're going to take that x plus 6 equals 0 and x minus 4 equals 0. Yep, x plus 6 equals 0, exactly. And then what is that going to give me when I solve it? When I solve for this x, that means x is going to become equal to what? -6. Good, because we're going to move that positive 6 over, right? So you do want to set it equal to 0, the whole factor, binomial, and then solve for x. And then so the x minus 4, we're going to solve for x. And so x is going to equal a positive 4. You guys are doing great. I feel like there's a lot of ways to ask this question. And as we well know, I'm sure you've already figured out, not every time I say it does it make perfect sense to you. Now, just to show you one more thing. So this guy, the x squared plus 2x minus 24. If we go to Desmos, if I can get it to come up with all the 100 things I have open. There we go. So ways that you can check this, or even like Be thinking about what you're going to find when you are doing these problems, whether it be they're looking for the factors or whether you're looking for the zeros and the solutions. If it's calculator inactive, obviously this is not going to help you much. But again, a larger portion of your test is active, so you have a calculator. When we solved it, we found that our factors, ooh, you're running around, there we go, were x plus 6 and x minus 4. It did graph on top of each other, like we lost our green one, got a purple one, bring our purple one back, which means our solutions, when we set that x plus 6 equal to 0, we got negative 6. So the x value is negative 6 when the y value is 0. And when we solved x minus 4, after we set it equal to 0, we got that positive 4. And you'll start to see that pattern, because sometimes if you just see the zeros, you could work backwards to find your factors, because you know that with practice, x minus 4 equals 0 is going to give me x equals positive 4. So you just move it back the other way to work towards the factor. And that x negative 6, if I move it backwards to where it's not x equals negative 6, but I wanted a factor, when it switches sides, it becomes that positive 6. So again, just ways that you can read this backwards and forwards and all the fun things that can happen with quadratics. And use Desmos to check and make sure you factored correctly, or even in that rate, make sure you solved correctly. Because if you got this far, these are your solutions, because x-intercepts are your solutions, your roots, and what was the other one? Zeros. All right, so GCF is the other thing that students get a little like hiccupy about. These are pretty basic. These are all binomials. GCF is greatest common factor. You're looking to see what the two, in this case 2, it really lives the most with trinomials and factoring. So just like the problems we were working just a minute ago, but with a number in the front that's not 1, and you can pull a GCF and make it a 1, which is your goal every time, always. But factoring by GCF. So if I'm looking at this, I like to look down, and this will seem really simple for these because they are small, but the process is right. So the first thing that I come across is that 24. So that's a coefficient of 24, and I have a constant of 6. So a whole number and a whole number. What is the largest number? Or actually, you know what? What is the first number that you think that 24 and 6 have in common, multiple-wise? 2. Perfect. Good job. 6. 4 is not going to work because 4 doesn't go into 6. Let's start with 2. And I'll show you how, because some numbers we don't jump as fast for, and 2 is one that you're always going to jump. 2, I got it. 5, I got it. 3, I got it. So 24 divided by 2 is going to give me 12. 6 divided by 2 is going to give me 3. So think about distribution property. Whatever's out here, when it goes back in, is going to give me the problem we started with. Our problem at this rate is you have a 12 and a 3. Do 12 and 3 have anything in common numerically that we could divide them both by? And if it helps, 3 is a prime number. So 3 you can only use itself and 1, right? 1's not going to help us because that just gives us back what we have. So is 12 divisible by 3? Is what you want to be thinking in your head. Can I divide 12 by 3? Yep, so I'm going to pull a 3 out here. So 12 divided by 3 gives me what? 4, good. And then we have x squared because we just haven't even messed with that yet. And then 3 divided by 3 gives us 1. 1 is prime, and 4 is fine because 1 and 4 are going to have nothing in common other than 1. My next thing I'm going to look at is my variable, that that x squared. There's not an x in the second term, so I can't pull out an x. They don't have x's in common. So now I've reached my simplest form inside what I call the hockey stick. And you're going to work down the outside and multiply these together. So 2 times 3 is going to give me 6. And then I have 4x squared plus 1. So like when y'all said, one of you said earlier, 6 is the GCF. But if you don't grab the appropriate GCF every time and you take it one row at a time, you could get there eventually. So you don't have to see it right off the bat. 5x minus 6x squared. So I'm looking at the numbers first. I have a 5 and a 6. Do 5 and 6 have any number in common? Other than 1? No, and in case that doesn't make sense to you, so 5 would be 1 times 5. You can't divide by 2, you can't divide by 3, you can't divide by 4, you divide by 5 again, so again you've come full circle. 6 is 1, 6, 2, 3, and then 3 times 2, full circle. Other than 1, these two columns don't have a number in common, so I'm going to move to the next is going to be an x. Do both of these terms have an x? Yes, I'm going to pull out an x. So 5 times x gives me 5x minus 6, because we haven't touched our numbers. There's 2 x's right here. That's what x squared means. And I pulled one of the x's out. So that's going to leave me with an x. 5 and 6 is fine. You have an x only in the second term. So you've now factored out the GCF would just be x in this case. All right, negative 3x cubed minus x. If you look at negative 3 and negative 1, 3 and 1, most of you are going to think there's not anything nice to pull out. If you can get things to a positive number, you are making your life easier for the future. So if they both have a negative, then we can pull out a negative. That's 3x cubed, and that's going to be plus x. Because now if I distribute that negative 1, I get all of this back. 3 and positive 1, that's just like our 5 and 6. They don't have anything in common besides that 1. So we're going to move down the line and we see an x cubed. Is there an x in the second spot as well? Yes, so we're going to pull an x out as well because they both have an x. And that's 3. There's 3 x's because that's cubed, so this is now going to become x squared. There's 1x, and we pulled 1 out, so we're just going to put a space holder 1, because then when I distribute it back through, I'll get back where I started. We're going to look down the side and multiply this together, so that's going to be negative x, and then pull what's left in our hockey stick. And now you factor the GCF. All right, this one's ugly. I did this to you on purpose. So the first number is 48. 48 and 18. What's the first number you can think of that we could pull out? What's the first number you can think of? 2. Perfect. Start at 2. If you're willing to invest, we can start really small. So 2 times what gives me 48? Two times what? Yep, 2 times 24. Perfect. And I'm going to leave my variable because we haven't even gotten there yet. 2 times what gives me 18? 9. Perfect. So 9, and we'll leave our x because we're not there. Looking at 24 and 9, is there another number that they would both have in common that I could divide them both by? 3. 3 is a good one. Let's pull out 3. So what times 3 gives me 24? 8. We're going to bring down our x's because we haven't gotten there yet. And what times 3 gives me negative 9? Negative 3, right? That minus 3, and then we're bringing down our x's. Now, 8 and 3, 3 is just 3 and 1, and 3 does not divide into 8, so we're done with our numbers. So we're going to be right next in line, and that's the x to the 4th. Now, you can pull these out 1x at a time, but hopefully you see that we have a lot of x's here, right? Still, and I'm going to go way down the page. If you take your lowest exponent, from whichever line you look at, so I already pulled out that 1, and now I realize how much paper I'm going to take. I know this means there's 3 here, and I know there's 4 here, so I can pull out 3. And if I have 4 and I lost 3, I have 1 left, right? So this guy is pretty much done. 8 and 3, we can't make better. There's only an x in the second term, not in both terms, so we're done there. Now we're going to multiply down. This 2 times 3 gives me what? 6, and then x times x to the 3rd gives me what? So x times x to the third gives me x to the what power? Because remember, when you multiply, you're adding exponents. So this is going to be 6x to the what? 4. Good, perfect, thank you. Again, remember when I said if you look and you see they both have x's, the smallest exponent is the one that's going to come out as your GCF every time. You can do it in single steps, like do x, x, and do it one time all the way down, but you would have done it 4 times total. So 6x to the 4th, we open our parentheses, it's 8 minus 3x inside the parentheses. And now you have factored by GCF. The way this is going to live to your advantage is factoring, like I said, huge, the 3 we just did prior to these GCFs, is whenever you see the front number is not 1, so in standard form, x squared, x constant, if it's not 1, your goal is to try to get that to be a 1. So if I'm looking at 3x squared plus 51x plus 216, see if I can get it to not be so blurry. It looks blurry on my end. Is it blurry on y'all's end? There we go. Ooh, it's worse. There we go. We're going to think about GCF. 9 out of 10 times, I would tell you to start with the first number because you want this to become a 1. So I'm going to pull out a 3. There's not an x in the back, so I know I'm not pulling out any variables. 3 times 1 gives me that 1, so that's going to be x squared. 3 times what gives me 51, and you should have a calculator if they're not numbers that you should know. So 51 divided by 3, and by that I mean like your basic multiplication tables, probably 1 to 12. Maybe they'll get to 13s, but really not, the 1 through 12s. So this is going to be plus 17x, and then 216 divided by 3, again, crazy number, so we would like to assume this would be a calculator active question. And then now, this is a trinomial where a is 1, so we should be able to factor it. Don't lose your GCF out here because he does matter. He determines how steep or how narrow this quadratic is when they graph it. But so if I'm now looking at x squared plus 17x plus 72, remember this is ax squared plus bx plus c. What goes on the top of our x? Which number is going to go on the top of our x? 72. Perfect. B goes in the bottom, so what number is going to go down there? 17. Now, this is that moment where I don't know if you might be smarter than me, but the factors of 72 are not something that I know off the top of my head. So that's when I like to use my calculator. Number I'm trying to factor divided by x, second graph. So I have 1 and 72. 2, and I'm not even putting them right in the table right. Sorry, 2 and 36, 3 and 24, 4 and 18, 6 and 12, 8 and 9, and then 9, 8 again. And I don't know if you can see my calculator or if it's too blurry. But so these would be for every x value, this is my output. Which pair? Our goal is to get 17. 1 and 72 are never going to come together to give me 17. 36 and 2 is 38 or 34, so that won't work. 3 and 24 will give me 21 or 27. That's not it. 4 and 18 give me 22 or 14, so not there yet. 6 and 12 would either give me 6 or 18 if I added them or subtracted them, but 8 and 9 will give me 17. Is the b value positive or negative for this equation, for this quadratic? Good job. Good job, guys. You saw it way before me. B is positive, so then our 9 is positive, for sure. Now we just have to decide, how do I get 9 to turn into a positive 17? What do I do to that 8? Add it, right? If I have $9 to get to $17, I have to add 8. So now I have x plus 9, x plus 8 are our factors, but don't forget we took out a 3. And so this is factored. This is your factored form. If you went to solve it, like you needed where is it going to cross the x-intercept, remember, what are we going to do to solve them? What am I going to do with those factors to solve? Set equal to 0. Good. Now, 3, we can set it equal to 0, but is 3 ever going to be 0? when there's not a variable there. I can't magically turn a 3 into a 0, so in that case, it doesn't really matter to the conversation of where is it crossing the x-axis. So this is going to be x equals that plus 9. If I'm solving for x, how am I going to move that 9? Yep, subtract 9. Beautiful. So that's going to be x equals a negative 9. For the x plus 8, if I'm solving for x, how am I going to move that plus 8? X equals a negative 8. So our solutions are negative 8 and negative 9. Our factored form would be this guy right here. All right, I have way too many examples, guys. I appreciate you as always.